Hey, me again. Section 3 for the quiz review, section 7.6 to 7.8. We are going to be using graphs this time to write an equation in factored form, so very similar to section 1, but this time we have to look at a picture of a graph in order to complete what they're asking us to do. So here we have our first graph. We have to first locate our x-intercepts, so we do that by looking at the x-axis. Remember, this would be a double root because the graph does not go through the x-axis like it does with that first root that I talked about, but it goes down, hits the x-axis, and turns right back around. So that makes it a double root. So it looks like we are counting by 1, so this is -1, -2. So I have one root at -2, and then the double is at 1, 2, 3. So I have x equals 3, and that's my double. Okay, so writing the equation, I'm going to start out with just y equals x plus 2 and x minus 3 squared because of the double. But I need to find a. So to find a, I use another point on my graph. Luckily, they gave me a point, 0 and 36. So I'm going to use that. X is 0, y is 36. So I'll have 36 equals a times 0 plus 2 and 0 minus 3 squared. So 36 equals a times 2 times -3 squared. So 36 equals a times -3 squared is 9. 9 times 2 is 18. So I have a times 18. Divide both sides by 18. So a is equal to 2. Remember, that is not our final answer. We are not done. We have to write the equation in factored form by plugging a in. So go back to my original equation. That was here, and I put in a. So y equals 2 times x plus 2 times x minus 3 squared. And that is your final answer for that problem. Is that easy to see or not really? I could rewrite it down here. Y equals 2 times x plus 2 times x minus 3 squared, because that was our double root. Okay? Moving right along on to B. Got to insert the picture. This is B, yes. Okay, I'm just going to move this up to the side a little bit so I have some more room. All right, so looking for x-intercepts and double roots. X-intercept here, not a double because the line goes through. X-intercept here, not a double because the line goes through. X-intercept here, not a double because the line goes through. Good. So we're counting by ones. It tells me that right here. So this is 1, this is 2, 3, this is 4, and this is -1, -2, -3, -4, -5, -6. This 10 here, by the way, is for the y-axis, so you don't have to worry about that. Okay? So 3 roots. I know that I have a third degree function because of my 2 turns. I forgot to mention that in part A. So remember, we count our extremes. So I have an extreme here and an extreme here. And then we add 1. So 2 extremes plus 1 means a third degree function. And you see I have 3 roots. So that works out nicely. So I'm going to come down here and start with my equation. I know I'm writing over the top of the graph. Obviously, you have room on your paper not to do that, but then I'd have to flip back and forth a bunch of times, and that just gets annoying. So y equals a times x plus 6, x minus 1, and x minus 4. Using our y-intercept that they gave us, 0, -24, plug in -24 for y. 0 for x would give me a +6 here, a -1 here, and a -4 here. I just skipped the step of actually plugging in the 0. Okay, so go through and multiply. -24 equals a times, this is a +24. So to finish solving, I would divide both sides by positive 24 to find out that a is equal to negative 1. So I can go back to my original equation, erase the a that I originally put in there, and change it to a negative 1, and now I have my answer because I just had to find out what a was and put it into the equation. So y equals negative 1 times x plus 6 times x minus 1 times x minus 4. I know I'm moving quick, but we've done so many of these, so I figure you should be able to follow right along, and if you can't, that's what the great pause button, rewind, and all of that stuff is for. So be my guest. Okay, C. So part C has, actually, I'm going to, I don't know how to delete something that cut. Ah, there we go. Hey, learned something new. Still learning, still learning. Okay, I'm actually going to leave that like that because then I can write at the top of the screen. Okay, so again, looking for zeros, looking for our roots, looking for our x-intercepts. I see we're counting by ones. Here's an x-intercept. That is going to be a double because it does not go through the x-axis. It touches it and turns around, which means this is also going to be a double because it does the same thing. So what are these numbers at? Well, this one is at a negative 1, and this one is at 1, 2, 3. This one is at 4. So I have a double root at 4 and a double root at negative 1. I'm just going to make a note of that. X equals 4, double. X equals negative 1, double, because now I want to erase these so that I have some room to write. You can leave them on your graph. You don't need to write all over yours. So y equals, it's going to look a little funny, but we have x minus 4 squared and x plus 1 squared. If I can get the squared. There we go. Okay, let's make sure. So there's 4 roots here, so that should be a 4th degree polynomial. Let's look at our extremes and make sure that's correct. So I have 1, 2, 3 extremes. 3 plus 1 is 4. So that's what I'm looking at, a 4th degree polynomial, 4 roots. Perfect. Okay, so let's go through and find a. So use the x-intercept, negative 48. So negative 48 equals a times, put in 0. So this is negative 4 squared and 1 squared. So negative 48 equals a times positive 16 times positive 1 is a positive 16. Divide both sides by 16. So a equals negative 3. So for your final answer, you go back and you write in the equation y equals negative 3 times x minus 4 squared times x plus 1 squared. That's probably really hard to read. Let's see if I can make it. That doesn't look any better. How about red? Y equals negative 3 times x minus 4 squared and x plus 1 squared. Okay. Last one in this section, part D. Here's the graph for that one. Same thing, looking for our intercepts. So here's one. Graph does not go through, so this is a double. 1, 2, 3, negative 4 is a double. 1, 2, 3 is a single because the line goes through the x-axis. And 4, 5, 6, 7, 8, also a single because the line goes through the x-axis. So looks like I have 4 roots, a double negative 4, a 3, and an 8. Let's make sure that's accurate by looking at our turns. So turn 1, turn 2, turn 3. 3 turns plus 1 is 4, so 4th degree, 4 roots. Okay, let's get going on our equation. Y equals a times x plus 4 squared. Oh, I wrote too close to the top. This is going to be annoying. X minus 3 and x minus 8. plugging in our y-intercept, we have 0, 384. I'm going to move and do this work down here. So I have 384 equals a times 0 plus 4 is 4, so that's 4 squared. 0 minus 3 is negative 3, and 0 minus 8 is negative 8. So 384 equals a times, multiplying all that gives me 384. What do you know? Divide by both sides, and a equals 1. Use that to finish off your equation. So back at the top, I can erase a and put in that I just found that it's a 1. So I'm going to put in the 1. And there's your final answer for part D. Y equals 1 times x plus 4 squared times x minus 3 times x minus 8. Okay, section 3 complete. On to section 4.